All right, our goal is to construct a truth table for the given logic circuit. We have the inputs P, Q, and R, and then we get some output. And in this logic circuit, we have an AND gate, an OR gate, and an inverter. Notice that there are 3 inputs. So in total, we're going to have 2 cubed possibilities. In other words, 8 possibilities. And our truth table will have 8 rows as a result. So let's construct that truth table. In this case, I think it's better just to use the language of binary numbers rather than say true or false, which is kind of weird to say in a logic circuit. At any rate, we have the input P, we have the input Q, we have the input R, and then eventually, to cut to the chase, we get an output, given those inputs. Remember, a 1 represents true, a 0 represents false, or we might say a 0 represents off, and a 1 on. We can get the inputs 1, 1, 1, or 0, 0, 0, or 1, 0, 0, 1, 1, 0, 1, 0, 1, or 0, 0, 1, 0, 1, 0, or 0, 1, 1. Let's get back to that logic circuit. So notice here we have an inverter. So the truth value is going to be flipped. This is also an inverter. Here we have an AND gate. And here we have an OR gate. Consider this first row. The inputs are 1, 1, 1. So this is going to be a 1, this is going to be a 1, this is going to be a 1. That P with that 1 goes to that inverter, so we get a 0. That Q, starting with the 1, goes through an inverter to get a 0. Now we have 0 and 0 with that AND gate. 0 and 0 is just 0. R starts with 1, goes to that OR gate, but so does that 0. So we have 1 or 0, which is just a 1. So that is our output. Let's try the next row. We have inputs of 0, 0, 0. So P is a 0, Q is a 0, R is a 0. P with the 0 goes to the inverter, so 0 to 1. Q with a 0 goes to the inverter, so 0 to 1. We have the AND gate. 1 and 1 is just a 1. R is a 0. We have that OR gate, so we have 0 or 1, which is just 1. Next row. We have the inputs 1, 0, 0. So P is a 1, Q is a 0, R is a 0. So the P, 1 to 0 because of that inverter. Q with a 0 through an inverter gives us a 1. 0 and 1 is just a 0. And then we have that R with a 0 to that OR gate. We have 0 or 0, which is just a 0. Let's move on. Now we have 1, 1, 0 as an input. So P is a 1, Q is a 1, R is a 0. All right, P1, inverter, 0. Q1, inverter, 0. 0 and 0, so that AND gate is just 0. R is a 0. And then we have that 0 to work with. So 0 or 0 is just a big fat 0. Let's go on to the next row. Here we have the inputs 1, 0, 1. So P is a 1, Q is a 0, R is a 1. P with that 1 goes to that inverter, so 1 to 0. Q with the 0 goes to the inverter, so 0 to 1. We have an AND gate, 0 and 1 is just a 0. R is a 1. We have an OR gate, 1 or 0 is a 1. So let's move on to the next row. And that row has a 0, 0, 1. So P is a 0, Q is a 0, R is a 1. P with that 0 goes to an inverter to get 1. Q with that 0 goes to an inverter to get 1. 1 and 1 is just 1. R is a 1. We have an OR gate. 1 or 1 is just 1. Let's move on to the next row. We have 0, 1, 0. So P is a 0, Q is a 1, R is a 0. So 0 with that P through the inverter is a 1. Q with that 1 through the inverter is a 0. We have an AND gate, so 1 and 0 is a 0. We have that R with a 0. With an OR gate, now 0 or 0 is just 0. So let's move on to our final row. We have 0, 1, 1. So P is a 0, Q is a 1, R is a 1. So P with the 0 to the inverter gives us a 1 so far. Q with the 1 goes to an inverter to get us a 0. Now we have that AND gate, so 1 and 0 is 0. That R is 1. We also got that 0. We have an OR gate. 1 or 0 is a 1. So here is our truth table. Our 8 possibilities. We have these different outputs depending upon those inputs. I'm the Amateur Logician, and you can visit my website at amateurlogician.com. I hope this video has been helpful. Good luck to you.